Hello, scientists. Welcome to room 9, our region's largest classroom. I'm Mr. Frills, the principal at KIPP Academy here in St. Louis. Today, I'll begin teaching science for 2nd grade, but all learners of all ages are welcome to join me in our class today. I'm so glad you're here. Let's see what we can figure out today. So today, we're going to start a new topic and think about how scientists can know about things that happened a long time ago. We think about things that happened a long time ago. Those things have happened, and the Earth has been around for a long time, and the world has been around for a long time, and the galaxy has been around for a long time. So we got to think about, how do we do that? We're going to focus on how scientists use observation, evidence, and scientific tools to learn more about, drumroll please, dinosaurs. Yes, dinosaurs. So I'm going to show you a couple pictures. And when I show these pictures, I want you to take a moment to look at it. I'm going to show you a couple pictures. Take a moment to look at it. Let's see if I can get the picture up. And all right, there you have it. The picture that I wanted to show you was this. So take a look at it. Remember, we were focusing on dinosaurs, and we're thinking about how we can learn more that scientists have done, about what scientists have done, to see what happened a long time ago. So as we explore scientists, we have to also explore their tools, including the thinking tools and the way that they figured out what dinosaurs were even like when dinosaurs aren't alive today. I'm going to show you more about what they do and how they do that. Scientists, that is. So I want you to see this. Let's take a look at this little bitty piece here. You see, it's a piece of a puzzle. And it's a small piece of a puzzle. But what do you think is the full picture when we zoom out to see the whole picture? What do you think this full picture is of the complete puzzle done? What do you think? You probably think it's a mountain. You probably think it's a dinosaur. I know you think it's a dinosaur. You probably think it's a house. But let's see. Let's take a moment to look at the full picture, and then we'll think about it from there. This is the full picture. We see that it probably didn't look like anything that you thought it looked like. But it's interesting because this is what paleontologists do. Paleontologists are scientists who study dinosaurs and other ancient creatures. They often find one bone at a time, and they find one bone that ultimately is a part of a larger picture. Do you think that it's difficult to make models of ancient creatures without all the pieces? Why or why not? Scientists, paleontologists, do this. They may find one bone or a big bone or a small bone, and they're trying to put together the entire creature itself. Just like what we first started with here. They're trying to take a piece of the puzzle and then make it into a larger thing. This is what paleontologists do. Some of the ways that they do this are like this. They use the science and engineering practices. They ask questions, they define the problems, they make a model and use it, they investigate what will you do and how will you do it with the little magnifying glasses. They look at the data and interpret it. They say what's happening and why and develop a solution. They make a claim, and they use their math and thinking. All these things are what scientists do to make sure they have a full understanding of what happened in the past, as well as make sense of what's happening now. Today we get to be paleontologists. Yes, paleontologists. Some paleontologists dig for years and years and never find anything. Sometimes they dig in hard rock, and other times the bones that are right under the surface are covered by sand. Some students, like you, may have explored digging up things in the backyard or outside your school, or even in the street, or in the lot in your neighborhood. Today we get to do some of the similar things just like that. We're going to engage our practices like scientists, the ones I just named for you, so you can learn more about the world of engineers and how they solve problems. So I have something in front of me that I'm very excited about. The thing I want us to think about first, though, is how are we going to capture our thoughts as we look at each one of these things? How will we capture our thoughts as we look at each one of these things? Because today, again, you get to be paleontologists. The first thing I want to do is say what materials we have. So today we have an aluminum pan filled with sand, and under the sand are some things that we'll be digging for. Under the sand are some things that we'll be digging for. We have our paintbrush, we have our tweezers, and we're ready to get to digging. But I want to make sure that we capture our thoughts as we see all the things that happen in our pan as we continue to work towards digging for dinosaurs to then ultimately see the practices that were used to find out more about what happened a long, long time ago. The thing I want to name is that as we find and search the things that we look for, what we should try to do is draw what we think when we see the bone. We'll take a moment to draw what we think the animal actually looked like. But now, let's dig in. So I have my pan here. I'm going to tilt down a little bit so we can dig together. So with my pan, I am just going to move through just a little bit to see what I've come up with here. As I dig through, there's a lot of dirt. And as we just learned, some paleontologists dig for their entire life and never find anything. But that's because they were looking in the wrong spot. I see something here that we may be able to find. As we continue to dig through our sand to find what we're looking for, we should start trying to make some predictions, like scientists do, about what we find. Before we go any further, I want to pause and see, what do you think we've found so far? What do you think it looks like? What prediction are you making? What kind of animal was it? What did it look like? We see this one small part of the bone, but do we think it's a big bone? Do you think it's a small bone? It seems like it just keeps going. So maybe we can see if we can find something down there. Let's keep going. Dig, dig, dig. Dig, dig, dig. Wow, it just keeps going. Must be a big bone. We got to be gentle because we don't want to mess up the thing that we're digging up. Oh, I think we found the end of it. So now I'm going to pick it up with my tweezers. And now I have the bone that we have. So I'm going to sit it to the side here because I see that there's more to be dug up here. Let's see. We're still digging. Still digging. Dig, dig, dig. Dig, dig, dig. Let's see. If I were to grab this guy here. Oh, wow. This was another one. Wow, so we have 2 bones. Let's take a moment to pause and look at our bones here. Let's see. So these 2 bones look very similar. Let me take these bones. I'm going to try to draw a sketch of what these bones could possibly be. Because once we draw a sketch of the bones, then what we could possibly do after that is try to get an idea of what the actual dinosaur could have looked like. So let's start with the bones. I'm going to sketch the 2 bones that we have here. To me, they look interesting. They look like this. That's pretty close, right? Look at that bone, look at that bone. I mean, come on. It's identical. So now, when we look at that, we have 2 of these, and this bone looks like this. I'm wondering what part of the body this could be. I'm gonna make a prediction based on what I see here of what I think this part could be. My brain is telling me that this probably could be the legs, especially given that I found two of them. So there'd be two of these that sit here and look like this. But now we gotta think, what does the actual dinosaur look like when we dig it up? What did it look like when it was fully grown, when it had muscles and skin and teeth? What did that look like then? So now I'm gonna try to draw a sketch based on our two bones here to see what it possibly could have been as a fully grown dinosaur. I think that those two pieces, I think those pieces were the legs. And as a result of them being the legs, I think that those two would be down here somewhere. Now that doesn't mean that just because we found two bones that look like legs, that doesn't mean that the animal only has two legs. It could have three. It could have four. We don't know that, but we got to make an educated guess around what we think. Now, I've never seen an animal with three legs, so it probably doesn't have three legs. Let's see if we can get an idea of what our animal looks like. This is what I think it looks like. This is what I think it looks like. What do you think it looks like? What do you think it looks like? As we take our guesses around what we think it could look like, we have to continue to keep in mind that there are a lot of dinosaurs in the world back when they existed. And as a result of that, there could be so many options. So our goal isn't so much to be right about our answer, but our goal is to explore a little bit more about what scientists do to find out what happened a long time ago. And one of the things they do is they use tools like brushes and tweezers and other grips to then go digging to find what remains are left in the earth that could give us clues about what used to happen. In the same way, this bone gave us a clue about what this dinosaur could possibly have looked like. Let's see if we keep digging to see if we confirm what we came up with back here. Let's keep digging. I think we have a bone back here somewhere. Let's make a prediction. Do we think that it's going to be bigger or smaller than the bone that we just had? Than the two bones that we just had? It's already seeming like it may have some weight, and it may be a little bit bigger. Let's keep going. Wow. So yep, it's definitely bigger. Definitely bigger. Would you look at that? Great. Now let's grab and see what we can. Oh my goodness, this is a big one. Wow. Okay. So this is what we came up with here. This makes me feel like I might want to change my prediction, because I thought that it was an animal that looked like that, but it feels like this would be the spine, and that this dinosaur goes like this. Maybe. So if I had to sketch that bone, this is what it would look like. Massive bone. Grab my marker. This time I'll do it in red so we can get a good look at it. I'm going to do this bone just across here. So it looks like there's a little bitty tail bone down here, and then it goes all the way down, and then it has some little things here. It's a little rounder, not pointy. Round. This is that bone. So now that we think about it, I actually don't think that that bone would find its way in this dinosaur. So how would you change the drawing that we have here to be the dinosaur that you see here? To see the spine and bone that you see here? Let's think about it. So this is what scientists do, especially paleontologists. They dig up the work that they've done that's been left in the ground, the remains, to then continue to find more. So now, we've made a mess. But in our mess, we've done some learning. One of the things I want you to remember is that as we do this, the tools that scientists were using, not just the physical tools, but the thinking tools. And one of the thinking tools we have in our back pocket is to make observations, as well as make predictions based off our observations. And we've recorded our observations here. We have our bones, we made our predictions, we made a drawn animal. So now let's keep going to think about more about this. I think the last question I have about the bones is, what was the function? I know that I said that I think this one was a leg, but now I'm thinking this one could be the spine, which would probably be the biggest bone in the entire dinosaur's body. So that was helpful to know and helpful to make sure that we make that a prediction. And that's what scientists do. So now I have a book for us to read. And with the book that I want to read, I want you to think about what is it that we've learned so far about what scientists do to then find out more about what happened in the past. Let's start from the beginning. The name of the book is called Dinosaur Fossils. I just love reading books. Love it, love it, love it. You should too. Let's start with that first here. A giant discovery. Dinosaurs haven't lived on Earth for millions of years. How can we possibly learn about creatures that don't exist anymore? How did they live? What did they eat? What did they look like? Let's see. Fossil formation. Fossils are only found in sedimentary rock. This type of rock forms when layers of silt, sand, and mud build up at the bottom of lakes, rivers, or oceans. Over time, the weight of layers turns the sediment into rock. An organic material caught in the layers becomes fossilized. Like the example of this real-life skeleton of a dinosaur. Trace fossils. As dinosaurs moved, ate, and slept, they left behind traces of these activities. Dinosaur trace fossils include footprints, nests, and claw marks. Give paleontologists a glimpse into the lives and habits of dinosaurs. Wow, look at those footprints. They're also massive, super huge. Dinosaur mummies. Dinosaur mummies are extremely rare. A mummy is a body whose skin and sometimes organs have been preserved. Only 4 mummified dinosaurs have ever been found. Dinosaur mummification is unusual because many conditions have to be just right for the soft part of the body to be preserved. Has to be just right. The conditions have to be just right. That probably makes it hard for paleontologists. Because if the conditions aren't just right, it makes it a little harder to then be able to prove or make a prediction around what you think has happened in the past. Tiny relics. When we think of our dinosaur fossils, we often picture the massive bones of a towering sauropod. But were all dinosaurs giants? Not all. In fact, some dinosaurs were no larger than a chicken. No larger than a chicken? That must have been a small dinosaur. Who knew? Massive monsters. The fossil record shows us that millions of years ago, huge dinosaurs roamed Earth. Some, like the Sauropodon, were 60 feet, 18 meters. 60 feet. That's a building that's at least six floors, and weighed about as much as 15 elephants. 15 elephants. What massive monsters. This is the dinosaur that I thought we had when we looked through our dirt and found our bones. Deadly dinosaurs. One thing that the fossil record makes very clear is that many of these dinosaurs were fierce predators. There is evidence that they were built to hunt, grab, and kill prey. All the better to eat you with. Polar dinosaurs. 100 million years ago, Africa, India, Australia, South America were connected to Antarctica. This landmass was called Gondwana, drifted south until it was inside the Antarctic Circle. The fact that similar fossils are found in these areas help prove the theory of continental drift. So they're saying that the continents were closer together at one point, but now that they're finding dinosaurs that were similar, that are identical bones in different parts of the world, that makes them think that the dinosaurs couldn't have swam, so that means that they must have drifted apart because the continents used to be closer together. Flying reptiles. Pterosaurs took to the skies over 230 million years ago. These winged creatures lived among the dinosaurs and even went extinct around the same time. But they were not dinosaurs. They were flying reptiles. Flying reptiles. Who knew? Behave yourself. It is difficult for paleontologists to know exactly how dinosaurs lived, moved, fought, or protected their young. They can only look at the fossil record left behind for clues. New technologies are helping scientists better understand dinosaur behavior. Interesting. So as they continue to think about the dinosaurs, they want to learn more about how they moved, lived, fought, and even protected their children. The Great Dying. Paleontologists look at the fossil record to find out what happened to dinosaurs. It is clear that they died out. But the question is why? Impact. Scientists have found that a meteor at least 6 miles wide hit Earth near Yucatan Peninsula in Mexico about 66 million years ago. An impact that large would have caused a lot of damage. It could bring about tsunamis and earthquakes, killing the dinosaurs or their food supply. Ice Age. You may have seen that movie. Another theory is that there were many volcanic eruptions around that time, and the ash from the volcanoes would block the sunlight, killing plants and changing the climate. This may have brought on an ice age. The land would then be covered in snow and fresh water and would be frozen. With storage of food and water, dinosaurs could become extinct over time. Interesting. And they learned all of this from just digging up and doing the research from the bones that they found and the earth that exists. Newest discoveries. There are still a lot of questions to be answered about dinosaurs. Paleontologists are finding new dinosaur fossils all the time. and each one helps them to better understand how dinosaurs looked, behaved, and evolved. Let's see. So there's so much we learned about dinosaurs today, but there's equally just as much as we learned about scientists. One specific scientist is paleontologists, the ones who dig up bones and fossils and other things in the earth to then make sense of what happened in the past, even hundreds of millions of years ago, especially when dinosaurs were alive. So now it's up to us as scientists to continue to use those practices to find out more. We now know about dinosaurs, and we now know about paleontologists. And so now you should be thinking, what other things happened millions of years ago, and how can you, as a scientist, spend time figuring it out? That's all I have for you guys this week. Keep your head up, scientists. You're going to keep growing those brains, and we'll see you guys next time.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.